combination circuits question number 2. In this particular question, the way this circuit is laid out for me personally is a bit difficult to read, so I'd probably set it out a little bit like this circuit underneath here. So it might be worth just pausing the video and just checking you see that and whether or not this helps you in any way. Because it's this circuit here that I'm going to be referring to as I go through my solution. Okay, so let's have a look at it then. If I've got this combination here, 24 volts across this resistor here, and that resistor is in series with the rest of the combination of the circuit. We've got a 6 ohm resistor, and across that we've got a 1.5 and a 5 ohm, and then across the 5 ohm we've got a 2 and a 3. So we've got lots of resistance combinations to worry about here. And actually finally, after this current flowing through this particular branch in the circuit, I would suggest the way forward is to work out what the resistance of this combination here is here. We've got a 5 ohm resistor in parallel with another 5 ohm resistor effectively, so that's quite straightforward to work out what that total resistance is. With that total resistance in series with this, I can then work out what the total resistance of that little part of the combination is, because that's in parallel with a 6 ohm resistor. And then I've got the total resistance of this particular part of the circuit. So I can put that in series with this and work out the current. Once I've got the current, I can find the voltage across this part of the circuit, which is what I'm interested in. Once I've got that, I know that voltage is the same across here, so I can then find out what voltage is across this bit of the circuit, this branch, and once I've got that, then it's straightforward to find out what the current is through this particular part of the circuit. So that's the way I'm going to approach the problem, and you may do it differently, or see if you can follow my method and do it for yourself. So I'll pause the video here and then have a go. Okay, so the first thing I'm going to do is find out what the resistance of this little combination here is. So I've got a 2 and a 3 ohm in series, which is 5 ohms, in parallel with another 5 ohm resistor. So using this formula, 5 products, 5 times 5 is 25 over 5 plus 5 is 10, gives me 2.5 ohms. You might have remembered that actually if the resistors are the series, are the same, then the total resistance is half of 1 ohm, which is 2.5 ohms. So there's a bit of a shortcut there. Now I'm going to work out I'm going to add this resistance, 2.5 ohms, to that, and then work out what that in parallel with the 6 ohm resistor turns out to be. And then from there add that in series, so then I've got the total resistance, and I can find the total current. So again, pause and see if you can carry on. Okay, so adding my 2.5 ohm resistor to the 1.5 ohm in series with it, this particular 1.5 ohm with this combination that we've just done gives me 4 ohms here. And now what I'm going to do is put that 4 ohm resistor in parallel with a 6 ohm and work out that resistor. So product 4 times 6 is 24 over sum 4 plus 6 is 10, gives me 2.4 ohms. So this whole part of the circuit gives me a resistance of 2.4 ohms. Put that in series with 1.6 ohms, gives me a combined total resistance of 4 ohms. Now I can find the current flowing, and hence, once I've got the current, I can find the voltage across this particular part of the circuit. So I know what's left across here, which is what I'm interested in here. And then I can go ahead and work out what voltage is across other parts of the circuit to allow me to find this current. So see if you can carry on and complete the problem from there. I'll work through the solution below. Okay, so I've worked out the current. I is the total voltage, which is 24 volts, divided by the total resistance, which is 4 ohms. So that gives us 6 amps flowing in the circuit. So if 6 amps is flowing in the circuit, looking back at the circuit here, if the current here is 6 amps, then I can find out what the voltage is across the 1.6 ohm resistor, and hence what's left. So that's what I've done. So I've worked out that what's the voltage across the 1.6 ohm resistor? It's 6 times 1.6, which is 9.6 volts. And so what's the voltage across the parallel combination? It's 24 minus 9.6, which is 14.4 volts. So I now know that there's 14.4 volts across here. So now I can work out what current is flowing in this particular branch of the circuit here, because I know that what this total resistance is here. I worked that out earlier. It's 2.5 ohms plus 1.5 ohms is 4 ohms. So if I know the voltage and the resistance, I can find that current. And then again, I can repeat. If I know the current, I can find the voltage across here. And so then I can find out what's left across here, which gives me the voltage across this combination here. And so I can find the current, which is the final part of the problem. So see if you can carry on and complete the problem. The solution will appear below. Okay, so the current flowing is through our little combination of 14.4 volts over 4. The resistance is 3.6 amps. So we've got 3.6 amps flowing in this particular part of the circuit here. So now I can find the voltage across there. So the voltage across that 1.5 ohm resistor is the current 3.6 amps times 1.5, which is 5.4 volts. So I've got 5.4 volts across here. So what's left across here can be 14.4 minus that 5.4, which gives us 9 volts. So I've got 9 volts across my little parallel bit here. And so now, what's the current flowing? Well, we've got 9 volts divided by 5 ohms through that little branch of the circuit, which is 1.8 amps. And that's the solution. Quite a long question, that one.